What's up, everybody? My name is Joe Scorsone. Channel is called Scorsone Enterprises, and today we're going to be going over another example for my parallel backtester written in Rust to use the data bento client called InkBack. It is on GitHub, it is open source, and to use the thing is free, but of course data bento data costs money. But yeah, we're going to be going over that example, so that way you guys can understand the flow I want you guys to take, how I want you guys to approach it, the mental model I had when writing it. Yeah, this is actually the schema I wanted, and I found it just really annoying to find reliable. If the data was reliable, it was like annoying to code in the environment. If the environment was nice, the data wasn't what I wanted it to be. But so I made my own, right? Just took matters into my own hands and made my own. And this is where I'm at now. So the last video I made was explaining how to use the footprint schema that I made for it as well. And today we're going to be doing the options on the underlying. I'm just going to go over the example strategy I have so that way you guys have a template. The example strategy sucks, but so at the end of this video, you should understand how I want you to work in this project so that way you guys can make better strategies, right? So we're going to hop right into that. I do have some exciting news beforehand, though. This is my X account. We're almost at 1,000 followers. Thank you guys so much for that. You're going to hear about everything on my X account first, everything like clear edge automation. It's just one centralized, I shouldn't say centralized, but just one slick, powerful tool to automate your futures trading. You can go across 20 brokers. You could seamlessly integrate it with TradingView strategies, and you get provided strategies when you sign up. It's amazing. I used the platform the other day. Very simple UI. I want to say simple UI. Very sleek, very aesthetically pleasing, easy to use, easy to understand, great documentation. It's just a GUI. You don't actually have to code anything yourself in it if you don't want to. So yeah, use the link in the description to sign up for this. It would help me out, and use the code in the description as well to sign up for this to get 20% off your first month. Speaking of Data Bento data, though, to use InkBack, if you guys sign up with Data Bento, you get $125 in free credits. They're not even sponsoring this. I just use Data Bento data in this project, and I love using this tool. So gotta pay the plug, right? Data Bento's the shit. And also my indicator made in collaboration with LuxAlgo. I use this to take all my automated trades. I had a profit factor of high in July with like a 70% win rate. I think it was like 1.5 in July with a 70% win rate. Tripled what the balance I was starting with. So took all those trades with this algo. And you guys could, if you want to see all the details of those trades, just go scroll on my X account for a little bit. I think it's in my highlights. Last day of July, profit factor 2.0. You can see every single trade I took. I posted all these. And yeah, I posted the losers too, expired worthless, minus 17.5. But enough about this. You guys didn't click on this video to hear about that. You guys clicked on this video to learn about InkBack. So in our main here, we have combined options and underlying schema. This is what we're going to be focusing on. We're going to be focusing on how to understand how I wrangle the data first, and then we're going to get into the strategy on it. The errors are just because I deleted some code, so that way we can implement it together, right? Have a little bit of fun. So in our fetch, we're going to come right here. We're going to match all of our schemas. We're at the combined options and underlying. We got to do a lot of requests for this formatting to work. And Data Bento has documentation about how to do something really similar to this with Python, with pandas. And I didn't know that polars was a thing in Rust when I was writing this. So I feel like I'm a little too deep to convert it now, but we're here. So we have to do a lot of stuff at first. It's kind of just boring and annoying. For futures, we have to make sure that we have the front month ID because the contracts expire and roll over. I'm going to assume you kind of know what you're doing. Like that made sense to you. Like when we talk about these financial instruments. If you don't, then just take your time, learn about this stuff organically, let it come. And then when you feel more comfortable, come back to a video like this, come back to a tool like this. If it's an equity, then we just need to make sure that we have the correct ID to request from. Little data set matching, right? Do we want the same data set like from the futures, or do we need Opera? Next, we need to do a lot of data validation. What did I just do? I actually deleted it. We got to do a lot of data validation right here. So we need to fetch on the definitions first. This is where we're going to get the class of the instrument, call or put. And if it's here, it's there, right? We're going to be cross-checking a little bit. at first. So if it's relevant, like it's a call or a put, and it's simply exists in this request that we did, so getting the instrument definition messages, then we need to store that. We need to store that. Yeah, we do need to store that because we're going to store it by the IDs, though. That's why I tweaked it out, because if I didn't know if we were just storing the messages yet. I wrote this a little bit ago. So we have to make sure that we have these instrument classes, call or put. If we actually have data in this, then we can move on further and match the underlying data and the futures data to it. So our underlying decoder is going to be one way if it's a future, one way if it's not. But bottom line is it's going to be this MBP1 schema, market by price, level 1. This is where we're actually going to be getting the bid price, bid size, ask size of the underlying. And so we did a bento with the compression and stuff like that to literally send it from them to me. There is a scaling factor in there, so we just got to get rid of that so that way it's human readable. Validate that that was correct, that like we're good with that, and then we can push our data to our underlying data. Timestamp, bid price, bid size, ask size, 6. So now we have underlying data points and option instrument definitions. So now we have to do a little bit of chunk processing because we can only do 2,000 option contracts at once. We need all the history for each contract. Do you see how that gets really annoying? So write our records, right? This is the header that we have right here for the CSV that we're going to write ourselves. I suppose a Parquet would have been faster, but I wanted a CSV so that way I could see it after I made these requests to make sure I'm storing everything correctly. So that's why we have that. So now from our relevant option IDs, the option IDs that we know exist and that we know have the instrument definitions on them, then we can go through, get those literal option contract symbols, and then we can request from it. Right, we're going to get all those option contracts into a vector, request all those individual contracts in the same request. We have to do a minimum of 2,000 at a time, though. Yes, that's necessary. We get deep. We get a lot of contracts, and that's good. That's what we want. So now we need to request that with the trades schema. This trade message is going to be where most of our information comes from. So we can see here that we have this definition message that we had before. We're going to be using, it's a mix. It's a mix of trades, it's a mix of definition. It's a mix of the straight up underlying bid and ask that we got from the MBP1 from before. But after we go through and we process all of that and we write all of that to a CSV, it's there. It's not going to go anywhere. And we can reuse it a bunch. So now, in our main, we can actually make a strategy around this. I wanted to keep all of the code for the strategy and the main function in the same function, or in the same file, excuse me. And I feel like I should put some of this into functions as well, but like I wrote like this one file. I'm talking a little bit about the mental approach I took to writing this backtesting system, but this one file starts on line 47, ends on line 754. I wrote this whole thing with just being very imperative, do the thing I need to do. I didn't think that much about Rust.clone overhead. I didn't think that much about functions, like clean code. You know what I mean? I didn't really care. I wanted something relatively fast, and that worked. And so I came up with this. Right, though. In our main, we have to load our data bento API key for our client, define a start and stop time, starting equity, how much we're going to put on each trade, and the actual client. We're going to build it from the API key. And then we could actually, we could set a CSV path. So we need a schema for the underlying and a schema for the options, right? So fetch and save CSV. Let's take a look at this right here. So we have a custom schema and a schema. So I said that a little incorrectly at first. We need a schema that's a data bento schema, that kind of type. Or we needed a custom schema that is an InkBack schema, one of mine, right? And so there's two slots right here. If you don't want to use a custom schema, you just need one, then you would just none it, right? But we're going to focus on this right Same thing for the benchmark, calculate benchmark, it's built in. Coming down a little bit further, and we're going to start at the top, right? Yeah. Okay, cool. So now, later on, once we figure out what our strategy is going to be, we're going to get all of our parameter combinations, and we're going to parallel iterate over it, and then get all of our backtests. So we're going to get to that in a little bit. We're going to put a pin in. Going to put a pin in it. It's my favorite corporate term. Put a pin in it at line 280, and we're going to come up here and we're going to think about how we're actually going to make our strategy. So it's going to be a simple, terrible momentum strategy. What do we need? We need a look back period, a threshold, profit target, stop loss, and the minimum days to expire. We have to filter our contracts a little bit. We also need to filter moneyness, but I do that later on. I don't have it as a parameter. Need some state tracking, underlying history, volume history, the position that we're in, and the current contract. So let's keep going. Our contract info is the instrument ID. This is pretty much call or put. No, it's not. The instrument ID, this is like the actual option contract ID. The symbol for the underlying, the strike price, expiration, option type, call or put, entry price, and entry time. Right, so I want to make sure I didn't lie to you guys right there. Yeah, current contract, that instrument ID. Perfect. So, position state as well, long, flat, or short, useful for tracking our orders and managing our risk in this. So, for our option strategy, new one, we're going to get our parameters right here and then return ourselves with these parameters. Right, self-explanatory, little constructor pretty much with the parameters provided. So a little reset method, a little helper. Now we could actually start implementing our strategy. So we need something to get our momentum. That's what our strategy is going to be based off of. We need a function to call that will get our, this is local to this strategy, so we could just access it anywhere, our underlying history, get our momentum from it. Our current price and our past price, the current price minus the past price over the past price is our momentum. So that's what we're doing to calculate our edge. Next, we need to parse our option information. So this is what's going to tell us if the option is a call or a put, the strike price of it, and the expiration. Expiration, we're going to filter expiration, but we don't do it here. This is to get it into, it is a U64, just like by nature. It's a time stamp, not like human readable, you know, month, date, year, whatever, right? So we're going to get that as that. Instrument ID with the literal contract is, and the symbol as well. That's what we got right here. This parse option info function is used when we actually need to track our contract and make sure that we actually have something to go off of. So let's keep going. We need to know if we should trade a particular option or not. This is where the moneyness and the expiration comes into play. So we don't want to trade options that are too cheap, because those exist. Now, from this parse option info on our particular candle, we can get a, we don't use some of these like the instrument ID and locally in this literal function. The symbol in the instrument ID, we need the strike price, expiration, and option type. So check our current days to expiration and make sure that we are a little bit of reality modeling because it's a backtester as well. We don't want any look-ahead bias. And then we need to make sure that our minimum days to expiry is good, that our contract expires in more days than our minimum. Next, we need to get our momentum, and then we need to match it. So if the particular option that we're looking at is a call, then we're going to look to see if we can go long. If it's a put, look to go short. The strategy, particular strategy, is we get the moneyness of the option, how in the money it is. We don't want to go more than 20% out of the money. Trade calls on positive momentum that's over the momentum threshold, and then I suppose that this is redundant. We don't want to trade options that are the moneyness of the option. The option can either be 10% in the money or 10% out of the money, but we're filtering to make sure that it's not further than 20% out of the money. That's redundant then. I don't know why I left that in there. Good thing when I do these videos, because sometimes I notice stupid things I do. But if all those criteria are true, then we could buy that option. And then the opposite for the downside for the put. But the nice thing is that it is still considered a buy. And I do support limit orders now too. I didn't have that last time in the footprint schema, but I do support limit orders now. So there we go. Now in the actual strategy, and we have this should exit position that pretty much checks take profit and time to expiration. Now in our actual strategy, our on candle is what actually gets called every candle. And so then we can get from the candle, we can get the option price, the size from the candle. So then we can push underlying price, the size, the volume of it, and then we can manage our state, all the data that we have to calculate our stuff, and then check for exit conditions or check for an entry signal from the functions that we wrote before. Yeah, I'm going over it pretty quickly, but it's a public example, and this is already 16 minutes, and I want to get into the main a little bit. So now, in our main, we can actually set some parameters. So we need a look back period, momentum threshold, profit targets, stop losses, and minimum days to expiry. All that combined, get all these together. Maybe there's a Rust one-liner that makes this actually pretty, but just get all these different parameter combinations, and then parallel iteration over all those all those parameter combinations, excuse me, to then run backtests with those parameters. So the result will be a backtesting result with am I tweaking? Yeah, we're going to make a new strategy with the individual parameters that we're on, backtest that strategy, and we get that result back. So if we were to actually run this, like if we had, I want to do it from here, like if we have cargo run with all the code like this, I don't know why I decided to do it from here. I gotta actually bite the bullet and dual boot Windows and Arch and configure a NeoVim. I really gotta do it. I really do. But here we go. We can see I already had the file for that data. Data saved there. Our benchmark return, we're calculating that first. The return is 1.69%. Draw down with that. Testing all these parameter combinations, testing them all at the same time because we're doing a parallel iteration. And in that loop, this big one is where we get each result. So now we have this result, and here we can see the white is our benchmark, and the strategy returns. Yeah, they suck, but it's an example so that we can get a feel for how this actually works. But we're cutting close to 20 minutes. I don't really like to have these videos go that long, but that is the combined options on underlying schema in my InkBack backtester. I hope that you guys enjoyed this video. I hope that you guys go ahead and use InkBack. I hope that you guys give me critiques for InkBack and just use all the open source code I make. There's a lot of Ink products. There's a lot of it's written in obscure languages, I think, obscure like Rust and Zig, more so than other stuff. I don't have a single thing written in Python or Go that's an Ink product. I don't know. I did write something in C++ recently, and it's pretty sweet. I might open source it, I might not, depending on some stuff, but it's pretty cool. What languages do you guys want to see me code in? Because I want to write Go and Zig. You guys like to watch Rust, C++, and Python. I've been writing more C++ because I need to practice it, because I might just have to write it. C++ is like trying to get off the, like, it feels like you're trying to get off the grid by having 30 passports. It's just funky to me. I'm not too sure, but yeah, thank you guys so much for watching this video. Thank you guys for checking out all the stuff that I do. Links to all the stuff in the beginning of the video and InkBack and just everything will be in the description. Check that out. Subscribe to the channel for more. I will see you guys in the next one.